Today we're looking at the environmental system of the Beech 1900D, including bleed air pressurization, temperature control, and ventilation. The environmental system consists of the bleed air pressurization, heating and cooling systems, and their associated controls. Bleed air from the compressor section of each engine is used to heat, cool, and pressurize the cabin. A heat exchanger and two valves on each engine pre-cool the bleed air, which has been heated to around 200 degrees Celsius. Bleed air is also expanded to bring it to cabin pressure. Bleed air entering the cabin is controlled by switches on the co-pilot's subpanel, placarded bleed air valves open, environment off, and instrument and environment off. In the open position, the environmental flow control valves and the pneumatic instrument air valve are open. In the environment off position, environmental flow control valves are closed and the pneumatic instrument air valve is open. In the instrument and environment off position, all are closed. Instrument air is used for various types of pneumatic equipment, valves, and electrical controls. If heating is required, the air cycle machine bypass valve opens. When the cabin temperature controller requests cooling, the bypass valve closes. The temperature controlled heated air is then routed through the outlets in the lower cabin sidewall, crew vents, and defroster. When the air cycle system is producing maximum cooling, the refrigerant compressor is engaged, and the cooling cycle of the vapor cycle system is initiated. Cabin temperature can be automatically controlled by presetting the cabin temperature selector to the desired temperature and setting the mode control switch to automatic. The temperature control of environmental air can be controlled manually by setting the mode control switch to manual and holding the manual temperature switch to the increase or decrease positions. To provide the maximum cooling rate, select manual cool on the environment mode control. Continued operation in this position is not recommended, as it may cause ice formation in the air cycle machine. There are 4 additional manual controls: the pilot's air, defroster air, cabin air, and the co-pilot's air. The controls provide the maximum airflow in the fully out position and minimum airflow in the fully in position. If the cockpit is too cold, in heating mode, pull out the controls to maximize warm airflow. In cooling mode, push in the controls to minimize cooling airflow. If the cockpit is too hot, in heating mode, push in the controls to minimize warm airflow. In the cooling mode, pull out the controls to maximize cooling airflow. 2 fans, one acting as a blower, the other as an extractor, ventilate the avionics. The vent blowers are controlled by a 3-position switch, placarded high, off, and automatic, and the mode control switch. The blowers operate in the high position when the mode control switch is in any position. When in the automatic position, the vent blowers will operate at low speed when the mode switch is set to any position except off. Blower control is independent of all other components of the environmental system. The outflow valve, located at the rear of the fuselage, controls cabin pressure, dumping exhaust air to the atmosphere. An adjustable pressurization controller, mounted on the pedestal, controls the outflow valve. The outer scale, placarded cabin altitude, indicates the cabin pressure altitude the pressurization controller is set to maintain. The inner scale, placarded aircraft altitude, indicates the maximum ambient pressure altitude while maintaining the cabin pressure altitude. The index mark at the top of the dial is used to read the values. The selected cabin altitude may be between sea level and 10,000 feet. The rate of cabin pressure altitude change is controlled by the Rate Control Selector knob. The rate of change selected may be between 200 and 2,000 feet per minute. The 12 o'clock position provides the most comfortable cabin rate of climb. The cabin pressure switch should be placed in the pressure position. In the pressure position, the outflow valves are controlled by the pressurization controller. In the dump position, the cabin will be depressurized and/or remain unpressurized. In the test position, the outflow valves are closed. Before takeoff, the cabin altitude selector should be rotated until the aircraft scale indicates an altitude approximately 1,000 feet above the planned cruise pressure altitude, and the cabin altitude scales indicate an altitude at least 500 feet above the takeoff field pressure altitude. During descent in preparation for landing, the cabin altitude selector should be set to indicate a cabin altitude of approximately 500 feet above the landing field pressure altitude. The rate control selector should be adjusted as required, but the aircraft altitude should not catch up with the cabin pressure altitude until cabin pressure altitude reaches the selected value and stabilizes. As the aircraft descends below the pre-selected cabin pressure altitude, the cabin will be unpressurized and will follow the rate of descent to touchdown. Cabin pressure altitude is indicated by the cabin altimeter. The rate cabin pressure altitude is changing is indicated on the cabin vertical speed indicator.